NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
This is it. This is the predicted point of closest approach according to all trajectory calculations. And we've now passed the point of closest approach on a broad, sweeping swing past the planet, 2,480 miles above the surface.
The date was October 19th. NASA's Mariner spacecraft, after traveling 4 months and 217 million miles, began fulfilling its mission as it rendezvoused with the planet Venus. The Soviet Union also approached Venus, 2 spacecraft from 2 nations. Although the machines were of different design, their purpose was the same. At the Jet Propulsion Laboratory in Pasadena, the project manager for Mariner talked about the mission and some of the early results. Here's Mr. Dan Schneiderman.
This much we can say at this moment. The planet Venus is a very hot planet. The atmosphere is dense, and its primary constituent is carbon dioxide. Now, the Mariner spacecraft, by transmitting radio waves through the atmosphere, established many facts about the nature of the upper and middle atmospheres of the planet Venus. Now, though these many experiments were made and were successful, and we do have the data, there are many mysteries yet remaining about the planet Venus. For example, why the absence of nitrogen? Where is the water vapor? How does the temperature distribute itself over the surface of the planet? These mysteries will be solved by further analysis of our present data and hopefully by more experiments of this type in the future.
Because of these missions, we know more about the planet than ever before, even though Venus, the evening star, yielded only some of its mysteries. We are as near as man can get and live to the biggest of all thermonuclear reactions, the sun. Everything we do, all the energy we have, is made possible by the sun. It is an enormous, controlled, stable thermonuclear reaction. To study the sun and its influence on the Earth, NASA has built and launched a series of orbiting solar observatories. This is the latest, OSO-4. The 599-pound spacecraft is designed in 2 sections, an upper sail-like structure which carries the pointing experiments, and a 9-sided base section called the wheel, housing for the scanning experiments, batteries, and telemetry. OSO-4 was just recently launched. Commenting on its progress, project manager Lawrence Hogarth, Goddard Space Flight Center.
OSO-4 is functioning perfectly. It's doing the job that the solar scientists once done. That job is, first of all, to find out all we can about how the sun works, and secondly, to find out what the sun in its working does to the immediate environment in which the Earth exists and moves. We are finding out, in addition to details of the sun's operation, what is happening as a result of those operations in real time just outside the atmosphere. This is the environment that the astronaut will see. It may at times be a lethal environment. Our determinations may enable us to warn the astronaut that he is approaching a time of peril.
From its vantage point of 350 miles out, the orbiting solar observatory is returning information important to both those who will travel into space as well as those who remain earthbound.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.